Did the universe come into existence by accident? Or did something intend it, or intend us? A mathematician, John Lennox, a historian of science, Stephen Meyer, and a scientist, James Tour. I'm Peter Robinson. The director of the Discovery Institute's Center for Science and Culture, Stephen Meyer, started his professional life as a geophysicist. Then he went back to school and earned a doctorate from Cambridge in the history and philosophy of science. Stephen Meyer's most recent book, The Return of the God Hypothesis. John Lennox is the professor of mathematics at the University of Oxford Emeritus. He serves as president of the Oxford Center for Christian Apologetics. John Lennox's most recent book, God, AI, and the End of History. James Tour is the W.F. Chow Professor of Chemistry at Rice University, where he also teaches materials science and nanoengineering. Professor Tour holds more than 130 patents. His most recent book, The Mystery of Life's Origin. Steve, John, Jim, thanks for joining me. Two quotations. Here's the Oxford biologist Richard Dawkins in 1995, quote, "The universe that we observe has precisely the properties we should expect if there is at bottom no design, no purpose, no evil, no good, nothing but pitiless indifference." Here's the second quotation. This is a poem that dates back 3,000 years. Psalm 19. "The heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they reveal knowledge." Which of those two better reflects, not perfectly perhaps, but better reflects the most recent developments in science? Steve?
I think the psalmist has got it right. The good Professor Dawkins, who has a talent for framing issues beautifully, nevertheless gets it wrong. That the new developments in science, especially having to do with biological and cosmological origins, are pointing to the reality of a transcendent designing creator.
Jim?
I would think the psalmist has it much, much closer.
Much closer. John? Are you going to please stick up for rationalism, and which of those two?
I'll stick up for rationalism and say the psalmist has it exactly right. That this is a word-based universe. The fact that we can describe it in mathematics, the fact that biology uses language to describe its central features of DNA, and Richard Dawkins' statement is contradicted by his own life because he does believe actually in good and evil, apparently.
The Big Bang. Let's begin everything with an excerpt. There's a forthcoming documentary in which all three of you appear. It's called The Story of Everything. I believe it will be in theaters in the United States in April. Is that right?
The film will open in theaters across the country on April 30th.
All right. So, and it's based on your book, The Return of the God Hypothesis. And the documentary, as we will hear ourselves today, describes three of the most important recent-ish innovations in science. And we'll begin with the Big Bang.
If the universe was always here, if the universe was infinitely old, then there's nothing for a creator to do.
Steve, if the universe was always here, there's nothing for a creator to do, says Carl Sagan. During a scientific conference in 1927, a Belgian priest and astronomer named Georges Lemaitre shared a taxi with Albert Einstein. What happened during that taxi?
A fascinating story. Einstein's own theory of general relativity implied a dynamic, expanding universe outward from a beginning. He was unhappy with that conclusion.
Einstein himself.
Einstein himself. So he fiddled with his own equations to make sure that the term in the equation that described the outward push perfectly balanced with the gravitational pull, so he could depict the universe as static. Lemaitre worked with his equations and showed that even on his own terms, the universe was not static, and that it was a dynamic universe. But he also was well aware of the astronomical data coming from Mount Wilson in California, showing what is called red shift, that the galaxies are are moving away from us, and we can tell that because of the way in which the light has shifted in the red direction of the electromagnetic spectrum. And so in the taxicab on the way to this famous conference in Belgium in 1927, Lemaitre confronts Einstein with this astronomical evidence and with his own depiction, and relays his own work on his famous field equations. And Einstein is reported to have responded, he said, well, your mathematics is impeccable, but your physical intuition is abominable. And so he rejects out of hand the idea that the universe is dynamic and expanding. But 2 years later, Arthur Eddington at Cambridge urges him again to go out to Mount Wilson to see what Hubble has been seeing through the telescope. And there's some famous
Take a second to explain the red shift.
Yeah, exactly. Okay,
that's
so
important to understand.
Yeah, so the light coming from distant galaxies is, as the physicists say, shifted in the red direction of the electromagnetic spectrum. If you shine light through a prism, the light will separate into different colors, red to violet. The red light corresponds to longer wavelengths. So if an object is moving away and is emitting any kind of a wavelength, that wavelength will be stretched out. So if the object is moving away, it's going to stretch out, and the color of the light will shift towards the red direction. It will be redder than it would otherwise be. And so as Edwin...
The ship's horn is the ship pulls away from us to go off to sea.
Exactly, or think of the train whistle, you know, with the Doppler effect from high school chemistry. As the pitch drops, the wavelength is also stretching out. So as Hubble began to survey the night sky with these new dome telescopes that were just being built in the 1920s, his photographic plates and his spectral analysis was showing that the galaxies in every quadrant that he investigated were redshifted. The light coming was being stretched, which suggested that the universe was actually expanding outward as if from a beginning point. And this was the great discovery that led to people thinking about, well, what would happen if you ran that sequence in reverse? If you back extrapolate, if you think about, well, what would if the universe is expanding outward in the forward direction of time, what would have been like 1,000 years ago, or 1,000,000 years ago, or 1,000,000,000 years ago? However far back you go, you will eventually reach a point where all of that galactic material would have converged in the reverse direction of time to one point, which would mark the start of the expansion, but arguably the beginning of the universe itself.
So a young student at Cambridge, the physicist Stephen Hawking, in 1966 presented a mathematical demonstration of the singularity. I'm reading these words, but I don't understand them, John, which is where you're going to come in here. The singularity, the moment when all matter and light were infinitely tight. So as I understand it, the singularity exists somehow, I don't even know how to describe it, but it exists outside time and space because time and space haven't come into a being yet. So explain what this means, this singularity.
They're very difficult concepts, but what Hawking did was to confirm what Lemaitre predicted and what the redshift showed and the Hubble telescope and all the rest of it, and gave a stronger, more mathematical confirmation of it. And in more recent times, there are three brilliant mathematicians, Vilenkin, Borde, and Alan Guth. And they worked out mathematically that you just cannot have an infinite sequence going backwards in time. It's reminiscent of the old Kalam philosophical argument that you can't have an infinite sequence of steps backward in time. So from their perspective, it's established that there was a beginning. Whether you think in terms of multiverses or not, there was an absolute beginning. And that, of course, confirms the statement of Genesis, which states there was a beginning. And to my mind, it is absolutely fascinating because I was at a conference of some very high-powered physicists not far from here a few years ago. And I made the claim that Genesis, in the beginning God created, was relevant. And I was interrupted by a heckler who was a famous physicist. And he said, look, Professor Lennox, you are not saying to us, are you, that you believe that the first statement in Genesis has any relevance for us today? I said, I am. I said, of course, the Bible is not a textbook of science, but when it says in the beginning God created the heavens and the earth, it's talking about the same heavens and earth that you study as a cosmologist. Now, I said, the interesting thing is that for centuries, what we now call science was dominated by the idea that matter, space, was eternal, because Aristotle held sway. And it was only in the 1960s that the evidence started coming in that there was a beginning. Now, I said in my country of the UK, it was resisted by the scientific establishment.
And by Einstein himself.
Einstein himself, who did later change his mind, though.
So the notion of a Big Bang, if the proper way to understand it, even though there's a lot of math involved, this is strictly speaking a scientific finding. This is an empirical finding. No philosopher, on the contrary, Aristotle didn't predict it. We discovered it. Is that fair?
Yeah, I think we discovered evidence for it. In the 1950s, most scientists didn't believe it. It wasn't until 1964 with this discovery of the microwave background radiation.
Okay, that's another point. The microwave background radiation.
Yeah,
tell me what that means.
That was the convincing argument. This same thing that Steve talked about.
It's different from the redshift. Is it, or
a separate line of evidence that provides additional confirmation at the beginning?
Yeah, so there was further confirmation, and the scientific community was not there, and then all of a sudden, it started changing in the early 60s.
Okay.
Peter, can I take just another quick hit,
Sure.
cut at the Stephen Hawking result? Because what Hawking is doing...
He resisted it himself, didn't he?
Later, after he proved the singularity theorem, then he wasn't quite sure he liked his own result, yes. But the basic idea is actually quite intuitive. According to Einstein's theory of general relativity, which is just a theory of gravity, massive bodies curve the fabric of space, or what's called space-time. And Hawking realized, he was studying black hole physics in the 1960s, and he realized that in the forward direction of time, matter, according to the astronomers, was getting more and more diffuse as the universe expanded, which meant that the curvature of the universe was getting less and less pronounced. But in the reverse direction of time, the matter would have been more and more densely concentrated. And so as you go back further and further and further, that more densely concentrated matter of the universe is causing the space of the universe to become more and more tightly curved. And if you go back far enough, you eventually reach a limiting case where you can't go back any further because the matter is so densely concentrated, it becomes infinitely dense, and the curvature goes to an infinite. And at that point, the laws of physics break down, and that's what marks the beginning of the universe.
All right. So we have here, I said we were going to go work our way through 3 of these scientific developments. But John has already touched on this. The challenge to a purely materialist view of the universe from the Big Bang, if I have it right, is that there must have been a first mover. Where if there was a beginning, something had to begin it. That's the question, at least it raises.
If matter, space, time, and energy begin at a finite time ago, then before that, or independent of that, there is no matter to do the causing. So you can't have a materialistic explanation for the origin of matter itself.
Got it. All right. Fine-tuning. This is the second of the 3 developments. Once again, we'll begin with an excerpt from The Story of Everything.
The basic idea of fine-tuning is that the universe is just so, that its properties, the initial conditions, the so-called constants of physics, the laws of nature, rest on a razor's edge, so that if they were slightly different than they are in the actual universe, the universe would not be habitable. That is, it would not be compatible with light.
What's he talking about? Give us some sense of the kinds of parameters.
Well, the fine-tuning idea is just the idea that the basic parameters of physics fall within very narrow ranges, outside of which life, even stable galaxies, even basic chemistry would be impossible. So we've been talking about the expansion of the universe. It turns out that the force that is responsible for that expansion, called the cosmological constant, is fine-tuned to something like 1 part in 10 to the 90th power. A little smidge this way, a little smidge that way, you'll get either a heat death or a recollapse of the universe. The force of gravity, the strength of the force depicted by something called the gravitational force constant, the mass of the quarks, the elementary particles, all of these different parameters, the speed of light, they all fall within these sweet spots. So physicists are now talking about are living in a Goldilocks universe, not too hot, not too cold, not too strong, not too weak, everything just right.
So if I picture myself in a control room with knobs, any one of which, if some child walked in and bumped into any one of these knobs, the universe as we know it, and certainly human life as we know it on this planet, could no longer continue. How many knobs are there?
Several dozen, depending on which physicist you ask. The illustration that you cite is actually an illustration of one of John's teachers at the University of Cambridge, Sir John Polkinghorne, the famous physicist. He used to ask his students to depict the fine-tuning. He asked them to imagine a universe-creating machine with a knob for the strength of gravity, one for electromagnetism, one for the cosmological constant, a slider for the speed of light, and so on. And the point was that each one of those parameters are precisely set, and a little bit off this way or that way, and the consequences to the possibility of life in the universe would be catastrophic.
Life in the universe, but also the ability to do chemistry? Do you run into these in your life?
Well, actually, Steve was underestimating the number of fine-tuning parameters there are. If you just change the dipole moment of water, say that word again. The dipole moment of water. So just how much electron density there is on one side of the water molecule versus the other, just slightly, a fraction of a percent, very small, life becomes impossible. Everything in chemistry is balanced perfectly for us to have life.
Fantastic. All right, you're a mathematician. How improbable is life? Is there a way of quantifying this?
It's extremely improbable. I think a very good example of a reaction to an early form of fine-tuning was Sir Fred Hoyle, who was an atheist and who was my examiner at Cambridge. And he predicted a resonance in carbon, which was later discovered. And when it was discovered, his reaction was, nothing shook my atheism like that discovery. Now, Sir Roger Penrose is one of the most brilliant mathematicians in the world, worked with Stephen Hawking and so on. And he has an analogy in his book where he says, if you want a universe with the second law of thermodynamics, where even your Cadillac will rust, everything is running down, the Creator's aim, and those are his words, he's not a believer in God, the Creator's aim must be accurate to 1 part in 10 to the power 10 to the power 123 in order to get our universe. And many people have pointed out that if you put a 1 here and a 0 on every elementary particle in the universe, you still can't write that number out. In other words, the improbability is beyond our imagining. So the idea of a creator is extremely close when you see these kind of figures. And the important thing is the fine-tuning is something that has been scientifically established. They've got to explain it. And they don't have an explanation that actually works. Apart from the God hypothesis.
Everything filmed does a really nice job of telling the story of Hoyle's discovery of these very particular parameters associated with building carbon that led him to have this change of view. And he's later quoted as saying, a common sense interpretation of the evidence suggests that a super intellect has monkeyed with physics. So, famous in our fields. Yeah.
All right. The information enigma. I think I stole that term from your book. Again, the documentary.
Here we are, the reason there is a universe is pathetic.
Jim, I'm going to begin my line of questioning for you with my memory of what I think was a 9th or 10th grade science textbook, which described the Urey-Miller experiment. 1952, a couple of professors at the University of Chicago develop a closed system of glass tubes, and they insert water to represent the ancient ocean, methane, ammonia, and hydrogen to mimic the early atmosphere, and then they subjected it to electrical sparks to simulate lightning, and they produced amino acids. And what I remember, dimly, because it was a while ago, but what I remember was, the strong implication was We figured out how to do the origins of life. They came up with amino acids. Scientists will be working on this. Sooner or later, they'll come up with a living cell. Has that happened?
Watch out, you're going to provoke him.
No, that hasn't happened. That experiment, there's no doubt they made amino acids, but the amino acids were just a very small amount of what was in there. There were many other things, and you have to stop the reaction pretty early on, or the amino acids all get consumed. They undergo something called the Maillard reaction, where the amine groups reacts with an aldehyde that forms and it decomposes. The Maillard reaction is the reason that you put bread in the oven and it starts to turn brown and this crusty part over the top. This is what happens during that reaction. Everything decomposes. So if you stop it early, then you can find some amino acids, but there's many other carboxylic acids, many other amines. So you have many other components in there. It's just a very small quantity. And of the amino acids, you get the simplest of amino acids in a large amount, the glycine and the alanine, and the other ones in a very small amount. And so of the 12 or so or 10 or so that they did isolate, there's one greatly predominates, and none of that would be usable in nature. Plus, it didn't have chirality, and so that's why it never led to life.
Jim, this is more than 70 years ago. What have you chemists been doing?
That's right.
How come nobody's produced a living cell yet? What's going on?
What's going on? Because it was really premature to think that life would come from that. The more we learn about the cell, the harder this target gets. So every year it gets harder because the cell is
more we know, the farther the target escapes us.
Right, and so even if we move what we think would be a little bit closer, the target is moved miles away versus millimeters that we might think we're getting closer. And that's how we know we're not even close. So you can track, are we approaching a target? When will we have a solution? You track the distance to the target. And when the target is getting further away, much faster than we're approaching, it's not going to be next year that we find this. It's not going to be for many, many years. This is why I say all the origin of life researchers will die of old age before this is discovered. Their children will, their students will die of old age, and their students will die of old age. So when you join one of these research groups, be prepared to die of old age without solving this.
So what you mean to say is that 70 years after the Urey-Miller experiment, and a good many years after I and who knows how many other Americans read about it in science textbooks, the leaves on those trees, the fish in that lake, the four of us at this table, we have no idea where life comes from?
We have absolutely no idea where life comes from, none whatsoever. And when people will say that,
and you say that as a man who is a full professor at Rice University with 130 patents. In other words, this is not some snake handling crazy person from
850 peer-reviewed publications. He's one of the top organic synthesis chemists in the world. He knows the chemistry.
So the chemistry just doesn't work, and we're nowhere close. That's just one problem of 1,000 problems that have to be solved in order to get life. So we're very far from understanding where life comes from. And so there's other questions about why they would keep suggesting that we're close when we're not. But as far as where we are, nowhere close. Absolutely clueless on the origin of life.
Got it.
May I take a cut at the idea of the target receding?
Yeah.
Unpack that metaphor, because the target receding corresponds not to something changing in the cell, but rather our getting more and more understanding of the complexity of the cell. And one of the huge ironies of the 1952-1953 experiment with Miller and Urey is that in 1953, the same year when their publication comes out about the experiment, we also have the first elucidation of the DNA molecule with Watson and Crick. And what they discovered, and subsequent to that, was that the DNA contains information in a digital form, and it's part of a complex information processing system that makes life possible. So it's not just, amino acids are just building blocks of proteins. Proteins are important components in an information processing system that's reading the information from the DNA to make the important molecular machines.
How long is a typical strand of DNA?
Well, it depends on the organism. But,
a simple cell.
Simple cell.
Well,
yeah.
I mean, a human being, it'll be 2 meters long. I mean,
In each cell.
yes.
Okay,
yes,
so what you're saying is we now
it's
know-
rolled up.
3 billion
we-
characters.
we
in a
used
human
to-
being.
But in the simplest of cells, it's going to be at least thousands of units long. But the DNA is not a protein. Every one of these molecules, I mean, the amino acids are make proteins. DNA is an oligonucleotide. And so you need to solve the sugar problem, and you need to solve a base
If we were
problem.
to create this on our own.
Yeah, I mean, DNA is a whole different class of compounds. So there are 4 different classes of compounds that were made out of. None of these have been solved. Miller-Urey just looked at the building blocks of the building blocks, and that was a mess.
Okay,
And then you got to link the building blocks, and then you got to sequence them properly.
And they don't want to link.
Hold on. So grant every bit of that. But here's what's in my head is, if I understand it correctly, way back in the days of Charles Darwin, the general assumption about the single cell that it was a simple form of life. There was some sort of vague notion that it was like a little blob of jello,
Protoplasmic.
or that it was simple.
Yep.
And now we look inside every single one of cells, and it's as though we find a code or written instructions 2 meters long in every single cell. Is that correct?
Well, in a human cell, it'll be that long. In a
human
simple
cell.
cell, it'll be shorter. But you still have all these levels of molecules that you have to deal with. It's so much more complex than what you're thinking. So much more. So
it's more complex than my little
you're
brain.
just looking at one little thing. And so now when you look into the cell next to you see more that you'll have to solve in order to get the simplest of cells to work. So we want to look at the simplest of cells, something like a bacterium, something very simple. Even with that, there's so many layers of communication that you have to have. It's not just taking all these classes of compounds and throwing them into the lipid membrane. That would be like saying, I could take all the parts of the engine of my car, take them all apart, and throw them into the passenger compartment. And if I just wait long enough and shake it long enough, that engine would assemble, mount itself, and everything would start working again. Nobody would think that. That's exactly what you're saying if you had all the pieces.
These are crazy men. I want to talk to somebody reasonable. So, John, it's just a question of time. Don't we, the universe is X billion years old. Even if it did have a beginning, it's what?
13.8?
13.8 billion years old. 13.8 billion years is a long time.
But it's not a long time when you think of the improbability of this kind of thing happening. I think the thing that really gets to me is you talk about this being a couple of meters long, but it's information of an exceedingly complex linguistic kind. And language does not get generated by natural processes.
It's language.
It's
information,
language.
it's code.
It is language, information, code. And what Miller and Urey discovered was a couple of letters. And then once they elucidated the decoding the DNA, they realized that the letters are valueless unless they're in the right order. But it's worse than that. You mentioned the living cell. But you see, you need a living cell to get DNA. And you need DNA to get a living cell. So you're in the biggest of all chicken and egg problems. And the biologists will correct me. In systems biology now, they're concentrating on the fact that there's a great deal of top-down causation in this whole field. And there are levels...
Top-down causation, what do you mean?
Well, that you need the cell first to manufacture all the things that create it. And you have levels of complexity going from the basic DNA to epigenetics above it, the folding of the proteins, all this kind of thing. And in Darwin's day and even later, Miller-Urey, they hadn't the faintest clue of the nature of what they're dealing with. You can have 13.8 billion years. You can have 138 billion years. You could have 1,380 billion years. You're not coming close because it's in the nature of the thing that you do not get language-like complexity through natural processes.
So we're stuck.
Well,
If there's a code,
could
there has
point in a different direction.
Exactly.
Because whenever we see information and we trace it back to its source, we always come to a mind. Bill Gates has said DNA is like a software program. Richard Dawkins has acknowledged that it's machine code. Well, when we see a software program, we always know that it came from a programmer. In fact, whenever we see information, whether it's in software or a hieroglyphic inscription or a paragraph in a book or information embedded in a radio signal, you trace it back to its ultimate source. You always come to a mind, not a material process. So Jim has brilliantly shown how inadequate these undirected chemical evolutionary theories are. The flip side of that is that there's a positive case for a designing mind having played a decisive role in the origin of life, because as John has said, information is a mind product.
But science, the natural sciences, as Jim has said, can't give us that. That's what you're saying, isn't it,
So,
Jim?
I mean, I sit here listening to the three of you, and my little mind is struggling with all of this, because the answer, I mean, it sounds like a loophole now, an intellectual loophole, but the answer was all, oh yeah, okay, it's just more time. All we need is more time for these processes, for random accident to happen. But of course,
That's not chemically plausible.
But time is the enemy, actually.
Time is the
enemy. As soon as you have these molecules, they start to degrade. Just like if you have something that's valuable to you, and you put it outside, and it starts to rust. These molecules, if you just had one molecule of RNA, one molecule, it only lasts hours, and it's degraded. So you say, well, if you waited billions of years, it's degraded. Proteins will last on the order of days. That's it. So this element of time is actually the enemy and not the savior of this process.
okay, so the idea that the universe came about by means of totally undirected, impersonal forces, all three of you would consider that
Implausible.
preposterous.
Implausible in the extreme.
All right, and so, okay, so now let me ask you this. Why do all three of you get roughed up by your colleagues? Here I've got Jim Tour. I looked on YouTube. You got in a debate with some YouTuber called Dave Farina, who considers himself a science influencer or explainer.
3-5, which is what you need to have life.
Do me a favor here. I want you to read the title of that paper there. It's by your buddy, Jack Shostak. He's done some research on this.
Yeah, I know. And Jack Sostek even says he cannot get it.
And here's what he said in a recent YouTube. He claimed your work, quote, only serves to keep indoctrinated buffoons in their blind faith, close quote. That's not a very nice thing to say. Which brings us to Steve. Here's from Charles Marshall's review of your book, Darwin's Doubt. This precedes your book, The Return of the God Hypothesis. And by the way, this review appears in Science, which has got to be one of the 2 or 3 most esteemed scientific journals. Quote, the book's subtext is to provide solace to those who feel their faith undermined by secular society and by science in particular. Meyer's selective scholarship appears driven by his deep belief in an explicit role of an intelligent designer in the history of life, close quote. How come?
The reason for those quotes
Yes.
is that the people that wrote them do not take the scientific arguments seriously. And they are actually exemplifying what they're accusing Jim and Stephen of. And that was what I've seen all the time. They will not get down.
These are the defenders of the faith. These are the
But
defenders
no-
of the materialists.
Yes, I know. But they're not able to defend it intellectually, so they give these kind of ad hominem. Jim, and he will speak for himself, and Stephen have issued challenges to these materialists to come up with evidence, real argument. And do they, Jim?
Well, the YouTuber doesn't have the capacity to understand the science. So what I've done is I've challenged PhD chemists or biochemists to engage with me. I've challenged them openly on my YouTube channel. Others have reached out to them to meet with me. We'll go on a neutral channel. I'll go on their channel and we'll have this discussion because the chemist can understand what I'm talking about. YouTubers can't. So when I go to the people that understand what they're talking, what I'm talking about, they won't engage. So their silence says it all, because no answer is an answer in itself. They will not respond to the arguments because they see exactly what I see. This is not a mystery. What I'm bringing forth is quite obvious to the scientist. It's really quite obvious.
Any working chemist knows what you're talking about.
Any working synthetic chemist, organic chemist knows what I'm talking about. Anybody who's worked with molecules, they know exactly what I'm talking about, so they don't touch it. There's the more fundamental question is why? Why? But as far as the science goes, nobody's going to contest with what I say.
And this information problem is very fundamental, because what we now know in 21st century biology is that if you want new biological form, you have to provide, or something has to provide, new information. Charles Marshall, my critic there, to his credit, did do a debate with me, for a rather extensive debate. It's up online. And he was proposing, we were discussing the problem of the origin of the Cambrian animals, the so-called Cambrian explosion, which is an explosion of biological form.
In the fossil record.
In the fossil record. But before that, it would be required an explosion of information. And he had simply proposed, well, maybe before the Cambrian animals, there were some pre-Cambrian organisms that didn't show up in the fossil record. And I said, yes, but still to build them, you would still require information. The information problem is still fundamental. His comment in the debate at that point was fair comment. So this has not been solved by evolutionary theory, either biological evolutionary theory or chemical evolutionary theory. But again, to reiterate John's point, information is something that is produced by a particular type of cause of which we all know, and that is an intelligent mind. And we're finding at the foundation of life information encoded in DNA, expressed in complex information processing systems. It's absolutely exquisite.
So if information precedes the new biological form, I'm sure this is metaphorical, or I'm sure I'm getting this wrong, but is it something like the new species must be imagined before it comes into being?
Well, the species is a bit of a
or new form.
The fundamental new forms of life require, we know that
just require information.
We know that information is required to build them.
Okay.
Right. And we know that information comes from the mind. So when we see these explosions of new form, I think we are seeing evidence of the activity of a designing mind. Yeah.
By the way, so back in 2019, I recorded a show with you and David Berlinski and David Galerntner, and that was on
the mathematical challenges to neo-Darwinism.
To Darwin. Yeah. And the comments on this show on YouTube were scathing. Why are you wasting your time with these cranks? And so 2023, we recorded another show with you and John and Michael Behe, not the same topic, but similar topic. And the tone of the comments was completely different. Do you feel a change in the way you're being received? Is it generational?
Yeah, I don't know if it's generational, but something's shifting very fast. Yeah.
In my University of Oxford, and all three of us know this person, there's a brilliant scientist, Dennis Noble. He's a fellow of the Royal Society. He's regarded widely as the father of systems biology. And he is on record as a scientist to say that neo-Darwinism doesn't need to be refined. It now needs to be completely replaced. Now, the interesting thing is that there are some leading biologists in the world saying similar things. Many of them are still quite materialistic, but they've given up on this, whereas the general public tends to hang in with the old stuff, and they've never heard this.
Oh, I see. That's all right. You experienced the same sort of change, more openness?
Yeah, I think the papers are certainly being written differently. So the origin of life researchers are not making the gross extrapolations from a very small piece of data that they used to make. The press still hypes it up, and the origin of life scientists are responsible for allowing a lot of that to go forth, because a lot of times the press will ask you, did we get this right? And so they will have extrapolations there. So it's still in our textbooks. It still is there, but the conversation is beginning to change.
Peter, we're talking somewhat descriptively and maybe even a bit abstractly about the complexity of the cell. And I think one of the things that can be very helpful is to actually see an animation of what's going on in the way that digital code in the DNA is directing the construction of the proteins and the protein machines that we need to stay alive. In that little clip you showed of Jim from the Story of Everything film, comes right after an animation that shows that. And so that's one way, without having to do a PhD in molecular biology, people can get a little bit of a handle on what we're talking about.
But that animation is just one of a million different animated things that are happening in a cell. So you can't just solve that. There's so many other pieces that need to be solved in order to have life.
Wheels within wheels within wheels of complexity.
And it's a matter of perception. You quoted the psalm at the beginning. The heavens declare, that's perception. And one of the impressive things to my mind is the response that a mind is behind this is usually a matter of perception. If you see the word exit above a door, it's just 4 letters. Very simple, but you immediately know that whatever processes have been used to create that sign, there's a mind behind it. Why? Because it conveys meaning. It's got 4 letters. You take the 3-point-whatever billion letters in a DNA strand, and many of my scientific colleagues just look at it and say, chance and necessity. They'd never dream of doing that with the word exit.
Okay. One more clip from this documentary, The Story of Everything.
This is actually a big problem in evolutionary biology. It's called the problem of gratuitous beauty. Many organisms have beauty beyond anything that's relevant for their survival value.
Gratuitous beauty. Explain that.
Well, it's the idea that organisms have a beauty that doesn't in any way convey anything that helps them in the Darwinian competition for survival. It's unnecessary to help account for why they have survived. It's just there. I love tropical fish. I love to snorkel in Hawaii. And when you look at the patterns on the fish, it's really hard to believe that, well, the Hawaiian triggerfish has exactly that. There's one even called the Picasso triggerfish. It's so beautifully painted. There's all these different patterns and designs that really seem to have absolutely nothing to do with whether they're going to survive or not. Some of them are so brightly colored that they're almost saying, "Come eat me, eat me." They're not really helping in the process of survival. They seem to suggest that perhaps the creator was not only a good software programmer, but also a great artist.
And you can say the same about mathematics and art and music.
Well, okay,
they're not necessary for survival.
So let me ask you that here we are sitting in Salzburg, the hometown of Mozart.
Yeah.
If you were an evolutionist, whatever the term is, Darwinist, how do you explain the evolutionary process that produces Mozart?
Very badly.
No, come on, do your best. If you were forced to argue for the other side, what would you say?
Well, you must say, if there is no God behind this universe, you are forced by your worldview to say it must have happened gradually through infinitesimal steps over a long period of time. And you must say that driven by your worldview. It's nothing to do with science or observation or anything else. It's the only logical solution. And that has always been a big problem for me, that if you're sitting with an atheist hat on, you're forced into this. And so therefore a lot of things...
And that's not scientific.
Yes, it's not scientific. It's simply your belief system.
I see. So, could I thank you very much for the seminar, but I'm just wondering, this may get a little bit, I'm just going to ask you about your personal reflections, your personal responses to all of this. Well, here's Isaac Newton in the General Scholium that concludes the Principia. Quote, "This most beautiful system of the sun, planets, and comets could only proceed from the counsel and dominion of an intelligent
and powerful
being."
Yes.
All right, intelligence, powerful, got it. Can we get from the science to a being that is in some way or another, loving, merciful? Can the science get us to God as many religions suggest He is? Is there any, or do we need to just say, no, we're not going there. Intelligent design is simply a very limited finding that information is necessary for certain processes that we observe. Information comes from minds. That's as far as we're going. How do you handle this problem?
Well, my initial reaction is the one that the Christian apostle Paul mentions, that looking at the world, at the universe, we can reasonably conclude that there is an intelligent mind behind it. We have intelligent minds after all, and that it shows a beauty, it points beyond itself. But then you come to a completely different source of knowledge. If you go back to Francis Bacon, who's often called the father of science, he talked about two books. God has given us the book of nature and the book of Revelation in the Bible. And it seems perfectly logical to me. If the science is pointing towards an intelligence, the logical question to ask, has God revealed himself? Now you see, when it comes to me getting to know you, Peter, I could put you and analyze your brain waves, I could MRI scan you. I'll never get to know you unless you reveal yourself to me. Now, if you reveal yourself, usually in speech, of course my mind keeps working. I reason and see that what you're saying makes sense. And it seems to me the analogy is perfectly justified. God claims to have revealed himself in his word and in Christ. And we don't stop our rational processes when we see that revelation. We need our minds to read it and understand it. And it's when those two worlds come together, our observation of the world getting us as far as a God, a creator, but now at the level of revelation and another thing, our own personal experience as persons reacting to all of this and to scripture, all of that goes together and focuses on one thing. And it's the cumulative effect of that that means I'm sitting talking to you as a convinced Christian and a person convinced of the value of science.
Jim, how do you handle, I'll put it another way. You say in this documentary, I think it's your voice that's quoted, that in earlier times, Galileo, Kepler, Newton, all these men of science took for granted, as all of humankind seems to have done for millennia, that there was a creator. All right. Can a scientist in the year 2025 talk that way? Or do you personally have to be very careful about saying, here's the evidence, and I stop there?
Well, when I write scientific papers, I look at the evidence and I write certain things. There's other things that we're excluded from being able to write. We just look at the evidence and we report up upon it. We might make extrapolations, but no, I don't bring God into the scientific papers.
And that's the way it should be.
That's the way it should be.
Oh.
Yeah, I'm fine with that. But what you see is you see a regularity in nature. It doesn't have to be this way, but it is this way. And this is how we know that we have a God who has a consistency and a purpose. Parents who are consistent with their children are usually much better parents. And that's what children long for. They love for consistency. It's not that Poseidon is angry today and that's why we have the winds. I mean, he's not a capricious God. And this regularity is what drives us to say, hey, I can study something that would be in a plant and I can expect to see similar behavior in an animal. I can see this type of behavior. I can see the consistency of how molecules work. I can do the experiment in Austria. I can do the experiment in Houston, Texas. It's going to be the same way. It didn't have to be, but it is the same way. So what we can perceive by that is that we have a consistent God, and He is magnificent in what He shows to us. I mean, I see so much more than what you can see. So if I look at a leaf, I know in that leaf, there's this magnesium atom sitting in the middle of a porphyrin, which is 4 nitrogen atoms sitting there. And there is a funnel where light can come in, and that light hits the magnesium atom, and that will eject an electron. And that then starts a photosynthesis process. And that's what causes this plant to be able to take up CO2 and to release oxygen, take that carbon and make it a part of that tree now. And I know why the colors are changing here. Why are the colors changing? Because you have this chlorophyll and you have the number of double bonds are beginning to get oxidized and they're changing. And so you see this beauty to God when you get into the sciences that the common person cannot see. And I see all of this as soon as I look at that leaf in my mind's eye, because I've studied it at the molecular level, and then that gives me a greater appreciation.
And it's an appreciation of design. Can I go back to the quote from Newton?
Oh, sure, but
okay, yeah, go ahead.
You go back to that, but I want to ask you, because as I understand it, your work in intelligent design, you are attempting, as far as you are willing to go a little farther and say, actually, we can bring the notion of an intelligent mind into science, into work. Go ahead.
Yeah, into the question of origins.
Right.
Okay, there are different types of science. The type of science that Jim does is he's studying things, the regularities of nature at the bench. He's doing experiments chemically, with nanotechnology, various things. If you ask the question, what does nature ordinarily do? The answer to that question will necessarily be rendered in terms of material processes, because we're describing what nature ordinarily does. If, however, you ask the question, where did this or that feature of the universe or life come from in the first place? It might be that life, or the digital code within it, is the product of undirected material processes. But another possibility is that the information in the cell, or the machinery in the cell, or the information processing system in the cell, resulted from the activity of a designing mind. And there we need to do a different kind of science, where we bring in our knowledge of cause and effect in the present to reconstruct what most likely happened in the past. And because we know from our knowledge of cause and effect that it takes a mind to generate specified or functional information, when we find functional information embedded in a molecule, and we know that that's necessary to produce life, we can infer that a mind played a role in the origin of life. So that's a different, it's a reasoning about the question of design or no design within what are called the historical sciences. And that's a perfectly legitimate thing to do. The opposite would be to say, well, I have all this information about what life is made of. Now I'm going to ask the question, how did it originate? Well, I could, but since I'm a scientist, I'm going to say I have to limit myself to strictly materialistic explanations for everything. But then I might miss the right answer, because it might be that I'm looking at something that cannot be or is not produced by material processes, but which instead is always produced in our experience as a result of a designing mind. And that's what we're saying is absolutely the case about the presence of information in a living system.
And there's a little thing to add to that. What kills materialism for me is that information itself is not material. And that's the end of it. That science itself has shown us in this information age that information is an immaterial quantity that's not reducible to physics and chemistry. So that if we're going to study it at all, we've got to widen our definition of
reality.
What is
you buy this?
Science.
Oh, absolutely, I buy
to.
this. Information is not material. And we even see this in the scriptures. It says, in the beginning was the Word, that is information, and the Word was with God, and the Word was God. This starts with information right here. And then it was that Word. The Word became flesh and dwelt among us. And we saw His glory. Glories of the only begotten from the Father, full of grace and truth. That Word then took on the material. It starts with information, always starts with information, which itself is immaterial.
In the film, in The Story of Everything, Jim's got a great riff where he says, we're asking the wrong question. We need to start asking about the origin of the code. Not just the origin of the molecules, but the origin of the code that is stored in the molecules. That's the real question.
And the real contrast here is very vivid, because the materialistic understanding of the universe starts with mass energy or nothing, actually, and builds up by unguided materialist processes to produce information as an end product. Whereas the worldview we're talking about is the exact opposite. That mind is primary and mass energy in the universe are derivative. There's a colossal clash. And I think that's where we can begin to understand the so-called clash between science and religion. It is not a clash between science and God. It is that we're coming up with two diametrically opposed worldviews. And you can see that the issue is a worldview problem. Take the Nobel Prize for Physics. Very simply, many atheists have won it, Christians have won it. Their science doesn't divide them, but their worldview does.
All right, gentlemen, we could talk about this for ages. But last question. I began with Dawkins and Psalm 19, which deal with the nature of the universe. Let me close with a question on the nature of man. Here's a quotation that sums up the materialist worldview. It comes from a year, 1907, when I think it probably still seemed brave and new and fresh to express this point of view. The newness is gone, but in my judgment, the worldview lingers, it remains present,
Sure,
if not in the American Academy, dominant. And so I'm going to read you this quotation from 1907, Bertrand Russell. You knew where I was going with it.
I afraid so.
And then I'd like to hear, not so much how you would reply to Bertrand Russell, who's been dead since 1970 something or other, but how you would reply to some student, a kid at Rice, a kid at Oxford, who reads this and say, yeah, I think that seems to me to be the worldview that all the really cool professors have. How do you reply? How do you speak to that, to a student who finds this impressive? And here it is, here's the quotation. That man is the product of causes which had no prevision of the end they were achieving. That his origin, his growth, his hopes and fears, his loves and beliefs are but the outcome of accidental collocations of atoms, and that the whole temple of man's achievement must inevitably be buried beneath the debris of a universe in ruins. All these things, if not quite beyond dispute, are yet so nearly certain that no philosophy which rejects them can hope to stand. Jim Tour, how do you reply to that?
I would just say, how do you know that? How can you know that? Tell me, what's the measurement that allows you to know that? And it would wither immediately. There's no evidence that could show that.
John?
Well, I would say that statement, as my teacher of quantum mechanics, Sir John Polkinghorne, pointed out, is self-refuting. That if it was true, we couldn't possibly know it. And he points out that that kind of explanation reduces thought to the random motions of atoms. And so it dissolves thought, so that what he is talking is sheer self-contradictory nonsense. When I was in Cambridge, I saw in the window a book, Why I Am Not a Christian by Bertrand Russell. I walked up and down, dare I read it? I read it, and it confirmed my Christianity, because it seemed to me he had never begun to understand what the message of Christianity, or indeed biblical theism, was.
Steve?
May I segue from Russell back to the original quote from Dawkins, because they're very similar.
Sure, yes.
Remember his framing was
nothing but pitiless indifference.
Yeah, the universe we observe has exactly the properties we should expect. If at bottom there's no design, no purpose, nothing but blind, pitiless indifference. It's a wonderful quote in that it suggests that metaphysical systems of thought, worldviews, are as testable by looking at the world as scientific hypotheses are. And what the argument that we've been making, and the argument that comes through in the film you've highlighted, is that the big discoveries of 20th and 21st century of science are not at all what you would expect from a materialistic point of view. The materialists did not expect, they expected an infinitely old universe that never had a beginning. But what we discovered is that the universe had a beginning. They didn't expect that the universe would be finely tuned against all odds to allow for the possibility of life. When Hoyle discovered that, he was shocked, and it shocked him out of his atheism. Nobody expected the digital nanotechnology that's been found inside cells. And in fact, Dawkins recently was quoted as saying he was knocked sideways with wonder upon seeing an animation of the DNA information processing system that an Australian group rendered. So all of these things, the complexity of the cell, the fine-tuning of the universe, and its origin a finite time ago, are all completely unexpected from a materialistic point of view, but they're exactly what you would expect from a theistic point of view, that is to say, the worldview that affirms the reality of a transcendent and intelligent creator.
Steve Meyer, Jim Tour, and John Lennox. Thank you, gentlemen.